All right, let's talk about the standard form of a quadratic function. So by the time we're finished with this lesson, you're going to be able to graph quadratic functions written in standard form. Let's begin with the warm-up. I want you to pause the video, work these few problems, and then come back and check your answers. The first one was pretty easy, all laid out in slope-intercept form. So the slope is 3, and the y-intercept is at 0, 3. The same with this one, already in slope-intercept form. So your slope is -2, and it intersects the y at 0, -1. Problem number 3 required a little bit more work. We had to subtract 3x from both sides, then divide every term by 2. So our slope is -3/2, and the y-intercept is 0, 3. Let's look at our key concepts today. First of all, we're going to have some steps to graph quadratic equations in standard form. The first thing you need to do is put the equation in standard form, where y is equal to, and we've got the quadratic term plus the linear term plus the constant. Then we're going to extract the values for a, b, and c. So we've got a, b, and c listed, so we're figuring out what a is, b is, and c is. Then the next thing we need to do is find the axis of symmetry. This is the equation for axis of symmetry. Notice we haven't done this before. It's -b, so whatever b is, you take the opposite of b, divide it by 2 times the a, and it will give you your axis of symmetry. That's important for when we're graphing. To find your vertex, you're going to substitute your axis of symmetry, the x value, back into the original equation, and then you're going to solve for y. Then you're going to construct a table of more values for x and y. So you need to choose values for x to the left and right of your vertex. That's why it's important to find out where your vertex is, so you can figure out where to choose your values. Substitute x values into the original equation to find your y values. Then you're going to plot the points and connect them with a U-shaped curve. It's going to be shaped like a parabola because these are quadratic equations. So let's see what this looks like. We're to graph x squared minus 4x minus 4 using a table of values. We're to find the axis of symmetry, vertex, and the maximum or minimum value. Use a dotted line to graph the axis of symmetry. So they've given us a table of values. When we plot these points, where do you think our axis of symmetry is? It's at 2, because notice our y value, the lowest value is a -8. So our vertex is at 2, -8. The axis of symmetry is where x is equal to 2. Notice this, our parabola goes over 1, 2, 3 to the left, so it also goes 1, 2, 3 to the right. So it's the same amount of space on the left and the right of the axis of symmetry. That will help you pick your plots for your table of values. And of course the minimum is 8. This is a positive value for a, so we know the parabola opens up, so we have a minimum value. Looking at another example, for x squared minus 6x plus 5, they've given us a table of values for us to plot. Notice the vertex is at a 3, -4. Okay. Our axis of symmetry is where x is equal to 3. If we're looking at our points, see where we have a 2, -3. So you go over 2 more from this axis of symmetry. 4, -3. Our minimum is at a -4. Now we're to sketch a parabola given the information. The vertex is at a 3, 6. So 1, 2, 3, 1, 2, 3, 4, 5, 6. So I put a point there, that's our vertex. And it goes through the point 0, 2. Okay. So now the vertex at 3, 6 and 0, 2, the way you find this other one, We know that our axis of symmetry is x equal 3. This one goes over 1, 2, 3 places to the left of my axis of symmetry. So this is going to go 1, 2, 3 points to the right. That's how you can find the shape of your parabola. Very good. You are ready to begin the lesson.